Hey guys, good morning. So today we are going to do, we're kind of going to jam two lessons into one. They're actually two pretty short lessons that are pretty closely tied to each other, so I think it makes sense to do them as one. So I'm going to skip the do now for now. All right. And we're going to talk about equations with no solution. All right. So in class, it's a little bit different. We have a little kind of 5-minute brainstorming session where we try to come up with equations that we can't solve, right? Equations with no solution. And we usually come up with some wacky stuff. Someone will say like x divided by 0, since that's undefined, and all sorts of other stuff. And eventually someone comes up with something really simple like this, right? X equals x plus 1, right? Which on the surface looks like a pretty simple equation. But then when we think about it, fundamentally, we know x can't be equal to itself plus 1, right? X is equal to x always, right? So if we're thinking about a balance, and I'm doing this kind of using my hands, not realizing you guys can't see me, but think about, how I kind of model the triple B balance. The right side's always going to be one bigger than the left, right? Whatever number I substitute for x, this is never going to be true, because how would we solve this equation? Well, we would eliminate the variable. Now, what would that give me? 0 equals 1. So we've never seen this yet. Right? We haven't seen a scenario in which the variable was completely eliminated. Right? Now, what happened? Well, 0 is not equal to 1. So this is an example of what we call no solution. Okay, let's take a look at another one, right? 2x is equal to 2x plus 5, right? 2x plus 5 will always be 5 greater than 2x plus 5, right? So if I was to solve this, I'm going to get 0 is equal to 5, right? What happens if we've got something like this, right? 3x plus 4 equals 3x minus 7. Well, same thing, right? This is never going to be true. The left side here will always be 11 greater, because if I add 11 on both sides, it's really 3x plus 11 equals 3x. So same thing. Right? We're going to ask ourselves, is 4 equal to negative 7? Of course not. So these are all going to be examples of no solution. Now, what do they all have in common? Well, what they have in common is they have the same variable expression, but they have different constants. So this is what you're going to grab in your notes, okay? Can an equation have no solution? Absolutely. Look at all the examples, right? X equals x plus 1. 2x is 2x minus 5. 5x plus 4 equals 5x plus 7. Negative 3x plus 9 equals negative 3x minus 4. If you have the same variable term but different constants, what's going to happen? Well, when we try to solve the equation, the variable term will be completely eliminated. And that's what we see here. If we're solving the equation and we eliminate the variable and we have a false statement being 4 is equal to 7 or 9 is equal to negative 4. Now, if the statement is true, that's what we're going to talk about in the second half of the lesson. So we can do this in a couple ways, right? So my kind of quicker, for a lack of a better word, maybe students, or the students that pick up on things faster, okay? We'll say they're going to be able to look at a lot of these and say, okay, I've got the same variable expression, right? But I have a different constant. That's why it says plus or minus any non-zero number. That's just a constant. And for some of us, it's going to take a lot of time. We're going to have to actually eliminate each of the variables every time and then see what happens at the end. So we're going to model a lot of these. I'm going to do them quick, guys, because again, we don't want a 30-minute video here, and I've got a lot of things to get through. And since you've got the video, you can always pause, you can take notes, you can go back. All right, so let's see. Solution or no solution? Okay, well, this one's got 25 on both sides, which I don't really care about. So if I was to solve this equation, I get 25 plus x equals 25. So if I solve this, right, 25 plus x equals 25, I get x is equal to 0. That is a solution, okay? X equals 0 is no different than x equals 4, x equals negative 3, x equals 7/5, okay? It is a solution, right? Just so we understand that. Because sometimes we get caught up in, I want to put no solution for everything. I got 0, that's that's a solution. This does not look like any of the ones we looked at previously because the variable terms are different. Let's see what we had over here. X and x, 2x and 2, right? These are all the same variable expression. I don't have that here. It's a trick. I gave you the same constant, right, to kind of throw you off, but the variable terms are different. Now, what do we see for the second one? Well, I've got 2y plus 5 and 2y minus 3. So again, those of us that pick up on this quick are just going to jump right to no solution. Those of us that need to see a little more are going to say, all right, well, normally I would eliminate one of my variable terms. And what did that tell me? Okay, 5 is equal to negative 3. Well, as far as I know, 5 is not equal to negative 3. So if we need to go back, I eliminated the variables, and I had a false mathematical statement, so that proves to me that this equation has no solution, right? In the sense that if I had, and that's the way I always kind of bring it up in class, if I had put this on a do now, right, I'm going to put it up in the do now, I'm going to walk around the room, and in a couple minutes I'm going to have some hands up, and they're going to say, I think I made a mistake. And I'm going to say, you didn't make a mistake. You did what you were supposed to do, right? So even if you're not so sure about, you don't understand yet exactly what I'm talking about as far as, this part here, if you solve the equation, the variable is going to disappear. You're going to have a problem. So what's going to happen here? Well, again, the students that pick up on this fast are going to say, on the left side I have 7y plus 15, but on the right I've got 7y minus 3. So 7y plus 15 cannot ever be equal to 7y minus 3. 7y is equal to itself. So on the left side, I'm adding 15. And on the right side, I'm taking the same thing I started with, but I'm subtracting 3. That's never going to be true. All right, I'm sorry I'm kind of all over the place here, but I'm trying to sort of play both sides of this. Now, let's say you were just solving it, right? You're not really sure about that first part. So you eliminate the 7y, and you get this. And you say, well, that's not true. And that's going to point you in the direction of no solution. So again, for those of us that are picking up on this quick, if you see the same variable term on both sides, but a different constant, you know that there's going to be no solution. Okay? If the variable term is different, that means it's solvable. Did I need to actually solve it? Well, not really. All I wanted you to determine here is if there's a solution or not. All right, I can skip those. Maybe I'll look at one more of those. Okay, let's look just at number 6. So on the surface, it looks like they're the same, but obviously when we distribute, they're not. 7y minus 14 will never be equal to 7y minus 2, right? The right side is always going to be 12 greater, and if we really want to prove that, we do this, we get negative 14 is equal to negative 2, which of course is not true, and we'll say that there is no solution. All right, so here's your first now try. And again, I'm trying to make this quick because this is the first half of the lesson, and I don't want the lesson to be too long for you guys. So we're not going to solve and check if possible. You're going to tell me if there is a solution or no solution. That is all I need you to do. So you're going to say solution or no solution. All right, so hopefully we paused it, and now we're back. So if I'm combining like terms for my first one, I've got 11x minus 10 is equal to 11x. Well, I know that that just can't be true. Right? 11x minus 10 is always going to be 10 smaller than 11x. So that's going to lead me right in the direction of no solution. Right? And again, if you need to see more, what's going to happen when I subtract or add negative 11x on both sides? I'm going to get negative 10 is equal to 0, which we know is not true. Well, what about for the second one? Okay, well, for the second one, I have different variable terms, so I don't even really need to think about this. It's going to be a solution. And it turns out that x is equal to 0. So if I add negative 3x on both sides and I add 12 on both sides, I get 5x equals 0, so x is 0. I'm not even really concerned with the solution, honestly. We spent a lot of time solving equations. What I'm concerned with is that you can discern between what has a solution and what doesn't have a solution. So let's take a look at number 3. So let's combine my like terms. So that's going to give me 5y plus 8 on my left. And when I combine these like terms, it's going to give me equals 5y plus 16. Well, we know that can't be true. If I have 5y and I add 8 to it, and you have 5y and you add 16, you're always going to have 8 more than me, right? This is never going to work. If I eliminate my 5y's, I get 8 is equal to 16, which clearly is not true. So that's going to lead me down the road of no solution. All right, for the next one, let's combine those like terms. So when I combine all those like terms, it's going to give me 2y plus 6. And over here, when I combine these like terms, it's going to give me y plus 15. Well, that's solvable. I'm not even going to go any further, right? I have different variable terms. So I'm going to get y equals 9. Okay, so that wasn't too big of a problem. Let's do the same thing here, right? If I combine the like terms on my left, I get y plus 1.
And if I combine these like terms over here, I get 2y plus 6. I'm sorry, plus 2. I was looking at the wrong numbers. So I can solve this and get y equals negative 1, so that's going to be a solution. So the key here is that just because we talked about no solution doesn't mean that we're just going to indiscriminately put no solution on every problem. We're going to work through it. We're going to combine the like terms, we're going to distribute if necessary, and then we're going to assess the problem, right? So for the first one, I had 11x minus 10 equals 11x. That's no solution because 11x minus 10 is always going to be 10 smaller. The second one was solvable. We had different variable terms, right? And same thing for the fourth one and the fifth one. So we're not just going to immediately jump to no solution. We're going to do our best to see if we can solve it. All right, so again, guys, doing this in class is a little different. So now I'd say, well, if that's the case, right, how can we modify one of these equations and make it have infinitely many solutions? So I say something like, let's say we have 2x is equal to 2x plus 3. And I say there's a really small change that I can make to this equation. So instead of no solution, it has what we call infinitely many solutions, right? In other words, any number would work. And someone says, well, why don't we just make them the same? And I say, well, sure, right? In other words, let me rewrite this. Right, 2x plus 3 equals 2x plus 3. When will this be true? Well, that will always be true. 2x plus 3 is always equal to itself. In other words, if x is 10, I get 23 equals 23. If x is 0, I get 3 equals 3. If x is negative 50, I get negative 97 equals negative 97. So it's always going to be true. All right? So we can say 5x minus 7 equals 5x minus 7. We can say 3 times the quantity x plus 2 is equal to 3x plus 6, which is what I get when I distribute. So as far as our notes, right, we're going to get all this in our notes. So we're going to have a lot of notes to submit for our notebook check this week. So can an equation have many solutions? Okay, so we say that they have infinitely many, okay? Infinitely many solutions. Sometimes you'll see it written as an identity, okay, which is kind of, I don't want to say antiquated, it's just as valid, but the standards that we see, like on the Regents moving forward, we're going to see infinitely many solutions. And sometimes you see the solution set. So the solution set of a normal equation would be x equals 5 or x equals 3. In this case, the solution set is all real numbers. All right, so we're going to grab this all in our notes. So this is kind of like the opposite scenario, okay? So now we want everything to be the same. And this should be a little bit easier to pick out, right? I mean, we can look at this and say, wow, the left side is exactly the same. Now, obviously, if there's like terms in distributing, we need to do that first. But in the simplest sense, this is very easy to pick out, right? Whereas before, we'd have something like 7x minus 4 equals, 7x plus 10. Right, and we say, right? I mean, it's pretty easy that we say, okay, 7x minus 4 is always equal to 7x minus 4. It has infinitely many solutions. Or, if we don't recognize that and we end up solving the equation, instead of having some crazy thing like 5 equals negative 7, we're going to have 5 equals 5, or negative 7 equals negative 7, or 0 equals 0. So let's take a look at some of these. These should be a little faster. 27 plus 4x equals 4x plus 27. So both of these are 4x plus 27. Okay, so hopefully we could determine very quickly, just by looking at this, there's going to be infinitely many solutions. And going forward, I'm going to use IMS just to cut down on the writing and the time. Now let's say you didn't identify that. So you're going to say, let me eliminate my variable term. And then you're going to say, wait, I can't do anything. I don't have a variable left over. I have a true statement. 27 is always equal to 27, but I can't do anything else, right? I guess I could add negative 27 and get 0 equals 0. I don't know how much that helps you, but since this is true, I'm going to have infinitely many solutions. Let's look at number 2. Well, this does not look like number 1. It looks like what we did 5 minutes ago, right? 2y is equal to itself. So if I have the same variable expression, but I've got a different constant, hopefully we identify by now that that's going to be no solution. And again, if you're not sure, well, what happens if I add negative 2y? Well, I don't think 7 is equal to negative 3. And if that's true, if we eliminate the variables and we have a false mathematical statement, that's further proof that we've got no solution. All right, number 3, let's see who's not fooled by this one. 10 minus 8x is equal to positive 8x plus 10. Interesting. Negative 8x and positive 8x are not the same. They are opposites. So if I put this on the board as a do now, right, yesterday or a week ago, nobody would have a problem solving this equation. We would all eliminate the smallest variable term, and we get 10 is equal to 16x plus 10. And we would then say, okay, nice, two-step equation, 16x is equal to 0, divide by 16x is 0. Okay, solution. Once again, guys, 0 is a number. It's a valid solution. Okay, that is a solution. So here we have a good kind of situation here where we have three different scenarios, right? Number one is a clear case of infinitely many. Number two is a clear case of no solution. And number three is a clear case of a solution. So this would be good to have kind of side by side in your notes and maybe like kind of box this as a reference. So if you're having trouble with your homework, you're going to come back to it and you're going to say, well, what do I see? Okay, all of the same terms. Okay, great, infinitely many. Same variable term with different constants. Well, that can't work, no solution. Different variable terms, right away I know that there's going to be a solution. All right, so I'm going to do these kind of quickly. Again, I don't want this to draw out too long. So if I combine my like terms, I've got negative 7y plus 10. And here, if I combine these like terms, I get negative 7y plus 10. Wow, that looks exactly like what we just looked at. And I'm going to call that infinitely many solutions. Okay, for the next one, I'm going to combine 9x and 11x to give me 20x. 14 is just 14. And on the other side, I've got 20x, except when I combine my constants, I get 6. Okay, well, this looks exactly like the case I just saw for no solution, right? Same variable term, right, but different constants. Now, what's going to happen here? Well, I've got a bit of work to do here. Negative 5y plus 15 plus 5y is equal to, this is odd, 9y plus negative 9y is 0, is equal to 15. Looks like I need to do more. Okay, so here's my equal sign. Let me combine my like terms. Well, negative 5y and 5y is 0. That was a tricky one. So I get 15 is equal to 15. Well, what happened? My variable term was eliminated. All right, let me assess what I'm left with here. Is 15 equal to 15? It certainly is. That tells me that there are infinitely many solutions. All right, guys, so we're not going to solve and check these. We're already getting a little kind of long on time here. So what I want you to do is for numbers 1, 2, and 3, you're going to tell me, is there a solution, no solution, or infinitely many? Okay, so hopefully you paused and you worked that out. So for the first one, when I combine my like terms, I get 9x minus 10 equals 9x minus 10. Remember, we can write an expression in different ways as long as the terms have the right signs. So I can express negative 10 plus 9x is 9x minus 10, knowing that the 9x has to be positive and the 10 has to be negative. Well, that's great. I've got the exact same terms on both sides. There's my infinitely many solutions. Okay, let's take a look at the second one. I'm not even going to go too far here. I've got different terms. Solution. I don't know what my solution is. I don't necessarily care what my solution is, but I know there's going to be a solution. If I combine the like terms, 9y and negative 1y, I get 8y plus 9. And on my other side, I'm going to get 8y, but when I combine my like terms, I get plus 10. That's a tricky one. Will 8y plus 9 ever be equal to 8y plus 10? Absolutely not. So just to separate these, I'm going to say that because my variable terms are the same, but my constants are different, that's going to be no solution. All right, guys. So again, I apologize for going through these sort of fast, but again, there were a lot of, if I only do 2 examples for each of these, we're not really going to understand it very well. So for those of us that are like, wow, this guy went so fast, again, that's why the benefit of the videos is that you can go back, you can rewatch, you can take more notes. All right, guys, so this is your homework, okay? Determine the number of solutions. Now, you need to show the steps, okay? All right, so again, you're going to show the steps, show the work. So for number 6, there's going to be a bunch of things you have to do as far as combining the like terms. Same for number 5, number 4, and number 3. Numbers, number 1, you're going to combine the like terms, and then you can tell me. Number 2, you can just tell me, right? If you have more work to do that you want to show, that would be great. But you do at least have to combine the like terms, and then once you get to the point where you've got, 5x minus 10 equals 5x plus 3, or 7x plus 2 equals 7x plus 2, you can say what it is, whether it's one solution, no solution, infinitely many. Any questions, comments, concerns? As always, guys, you post your homework, post a question on Google Classroom.